So welcome to the problem solving lab of week 3. It's lecture 15. We will typically solve 5 problems which are related to whatever contents we have covered. So here is our mission for today's session. We will solve exam level problems. We will integrate multiple concepts such as force of interest and drop payment. We will practice for speed and accuracy. So our protocol will be, you will see the problem, you will understand the problem, pause the video, try to solve each problem within 3 to 5 minutes and then go through the walkthrough of the solution for each problem. Okay. So this is going to be our protocol, and I request you to solve the problem while watching the video. This is very important. Don't rob yourself of your learning. It is very important that you apply these concepts so that you can flawlessly execute whenever time required. Okay, so let us begin with first problem, which is complex rate convergence. So I have been given a effective discount rate, which is D, equal to 5%. I want to convert this D into nominal interest rate, which is compounded monthly, I12. So you are actually familiar with this. Just focus on periodic rate of return, convert D to I using the well known equation, the relation between D and I, and pause the video and solve the problem. I will see you on the other side. Okay, now that you have attempted the solution, let us look at what is the ideal way to do it. So here is a bridge that you have been given an effective discount rate. So you cannot directly link it to I12, but we have decided that there is a bridge equation, and that bridge equation actually connects D with 1 plus I. What was it? D is connecting to 1 plus I by 1 minus D inverse, right. So 1 plus I is equal to 1 minus D inverse. So if you use that equation, you will be easily able to connect it to 1 plus I. So we will do that. So 1 plus I equal to 1 minus D inverse, which essentially reduces to 0.95 inverse, and that gives me 1.0523. But what is the next step? I want to relate it to I12, I super 12. How will I do that? For that I have one more equation, 1 plus I equal to 1 plus Im by m raised to m. In this case, that m is going to be 12. So I will apply that particular formulation, correct. Now put in the appropriate values. You already know what is 1 plus I, just substitute it, take the 12th root of this using calculator, you will get this number, and then do appropriate arrangement, subtract 1, multiply by 12, and you will get the final answer to be 5.15%. Wonderful. Now you have cracked problem 1. Let us do slightly difficult problem which we have handled in lecture 12. Let us look at problem 2. I have a loan of $5,000, effective interest rate of 8%. I am supposed to pay 1000 rupees annually or $1000 annually. I want to find the size of the drop payment which will be made 1 year after last full payment. Okay. So now I hope you have understood. You have to calculate how many payments you have to make, and then what will be the last payment. So think about it, pause the video, try to solve the problem in 3 to 5 minutes. I will see you on the next side of the section. Okay, now that you have attempted this problem, let us look at equation of value at t equal to 0. So here it is mentioned present value of the loan, but present value of the loan is actually value of the loan because we are at time 0. So, the value will not change. So, it is 5000. And then if you look at our lecture 12 where we are looking at the geometric sums. So, that is present value of geometric sums, and we considered that to be equal to 1 minus v raised to n upon I, where v is actually 1 up where v is the value and it is equal to 1 upon 1 plus I. So, by connecting all these things, I know 1 plus I because there is a 8% return. So, it is 1.08. Okay. So, 1 upon 1 plus I will be 1.08 raised to minus 1. So, it becomes 1.08 raised to minus n upon I, which is 0.08. So, very clear. Now, there is nothing, it is just that you are trying to solve for unknown n. So, you solve for unknown n by taking our factor which tool that is very helpful, which is log tool. You take a log of that, you will get everything, and now your n becomes 6.63. So, how many full payments, how many partial payments? 6 full payments, and that 0.63 is the partial payment which you have to do at t is equal to 7. How do you calculate? So, you go up to 6 full payments of $1000, calculate the accumulated payment values and then subtract it from the value which is due at 6th point, right, t equal to 6. So, balance at 6 is the loan value at time point 6 minus the accumulated payments that you have made at 6. Again, this is a geometric sum problem which we have handled in that lecture. So, it is very simple, 5000 into 1.08 raised to 6 minus payment of thousands accumulated for 6 periods. So, discounted to a specific level 1.086, sorry, it is not discounted, it is interest gathered for those 6 periods, 1.08 raised to 6 minus 1 upon 0.08. So, if you solve this, you will come up with a figure of B6, which is 598.44. Now, are you paying this right away? No, you are not paying it, it is a drop payment. So, this particular amount will earn interest, or the interest that will be earned you have to pay. So, we have to look at how much 598.44 will earn in one time period. So, that is, we will calculate the payment at t equal to 7 by multiplying this B6 value by 1.08. That is what we will do, and it turns out to be 646.32. So, you have to do a final payment of 646.32 at time point 7. Okay. So, there were two unknowns. What will be the last payment, that is 7th payment will be the last payment, and how much you will pay, 646.32. Okay. So, now we have understood a complicated drop payment problem. Let us review what we learnt about the force of interest, and the interesting part comes when this force of interest is variable. So, here is the next problem where the force of interest delta t is 0.02 times t. Okay. Find the accumulated value of 100 at t equal to 0 for 4 years. Okay. So, you have delta t, you know this is continuous interest rate. So, you have to use integral appropriately, and the time period is 0 to 4. Now, pause the video, go ahead and solve the problem. Welcome back. So, I hope you must have got the answer, because it is very simple. Accumulated value is the initial capital, that is 100, into e raised to integral over 0 to 4 delta t dt. Delta t is given to me as 0.02 times t, correct. So, I will simply do the integral. Let us take the term within the parenthesis and solve the integral. So, integral 0 to 4 0.02 d dt will give me t square by 2. So, 0.02 will become 0.01 t square from 0 to 4. 4 square is 16 multiplied by 1 by 100, 16 by 100, that will be the answer, which is 0.16, correct. So, what you will do now, put this value in our accumulated value expression, 100 into e raised to 0.16, evaluate using using your calculator, it will turn out to be 117.35. Wonderful, you have solved third problem. Let us now do the last lecture's problem, which is time weighted return or the performance measurement of the portfolio manager. So, here is a question which relates to that. On Jan 1, you have a fund deposit of 100. At the middle of the year, July 1, your fund value was 120 before the deposit. You decided to deposit $80 on July 1, and then in December 31, at December 31, the fund value is 180. You have to calculate the time weighted return. How many periods are there? 2 periods are there. So, you have to calculate 1 plus J1, 1 plus J2, multiply them together to give you 1 plus ITWR. Pause the video, solve the problem. Welcome back. Let us see the solution. So, here is a visual where the time period is clearly given. Jan 1, 100 deposit, July 1, 120 was the value, plus 80 is the deposit, and December 31, 180 was the final end value. Okay. So, how will you calculate 1 plus J1 and 1 plus J2? Let us go period by period. Jan 1 to June 30 or July 1, where the end value is given. So, it is 120 divided by 100 will give me 1 plus J1, it is 1.2. Period 2, 80 in, so the total value will be 200. At the end we have 180. So, 180 divided by 200, so it is 0.9. So, 1.20 into 0.9 should give me 1 plus ITWR, which is 1.08. So, the time weighted return of your fund actually is 8%. Okay. So, this is not the investor's perspective, this is fund's performance. That is what you should always remember. Now, let us take one problem where we are solving for unknown interest rate, and that will be our last problem. Here you need to use interpolation formula is mentioned explicitly. If you recollect in the last in lecture number 13, we have done this interpolation formula, which is where we are guessing the two limits. Here the guesses are given to you 6% and 7%, and you are using the formula I, which is equal to IL plus present value low minus the target upon present value low minus present value high into I high minus I low. Here I high and I low are given to be 7% and 6% respectively. Now, read the problem, pause the video, and next on the other side I will show you the solution. So, the problem is very simple, you must have solved it, I am confident. So, your present value is 100, at 6% you can see, if you look at that discounting factor, which is V 50 into 1.06 raised to minus 1 and 60 into 1.06 raised to minus 2. 1.06 raised to minus 1 is my V and 1.06 raised to minus 2 is my V square. And then you can easily see this number that I got is 100.57, which is higher than the present value. And then if I go with 7%, you will see the same number, same calculation, which is lower than the present value. Okay. Now, you have to apply that formula, which we already know, present value high and present value low, interest high and interest low, all these things are well established. So, now we will go step by step execution. So, first of all I have IL, which is the lowest interest rate, which is 0.06 here, plus for higher interest, what is a present value low? Present value low in this case is actually 100.57, because this is corresponding to this 6%. So, this is PVL minus the target, which is actually 100 here, upon present value low minus present value high. So, always remember, this low actually gives you a high value, high actually gives you the low value, because your interests associated are low and high. Okay. So, this is 99, this particular term is 99, and this particular term is 100.57, and then this is interest high minus interest low, right. So, I have applied that formula correctly. Once I have applied that formula correctly, it is just a matter of algebraic computation to get the answer, and you will get the answer to be equal to 6.4%. That is all. So, we have actually done everything that we have done, all kinds of problems that we have done up to week 3. In the next week, we will actually deal with annuities, where we move from ad hoc cash flows to regular streams of payment or income. And we will discuss two concepts, as we are discussing present value and future value. Present value of annuity and future value of annuity, we have already shown you the glimpse of that, which is a geometric sum, but we will discuss that in detail. And then finally we will consider perpetuities. And before starting week 4, I urge you to complete the assignment 3, which will greatly enable you to understand the contents that we are discussing in week 4. Thank you.